How you doing? We are in volume three of the Sacramento State books in chapter two, and we're talking about effluent discharge and reuse. As a society, water is becoming a scarcity, and so we're really looking on, the water that we discharge from our wastewater plant. Can we reuse it? Can we use it for another beneficial use? Um, Most of us discharge to receiving waters, and so a lot of the plants, especially up in the north where we have a lot of rain, will discharge to a lake or body. Um, but the main reason, on page 48, the main reason to reclaim and reuse effluent from wastewater treatment plant is the need for water. Effluent reuse is considered when the volume of municipal water needed is not available, cost of purchasing available water is too expensive, surface waters are not available, or the cost of treatment is excessive, and groundwaters are either not available or cost of pumping or any treatment are prohibitive. You know, out west, there are a lot of states that do not have the luxury of having the mass amount of groundwater that we have or surface water. Some of those arid and environments out west or even overseas requires for the operator to use their effluent from the waste water plant to be used for another beneficial use. And we're going to kind of look into those, some of those areas. We want fit for purpose treatment. So wastewater treatment variations that produce a water of an acceptable quality for its intended reuse while minimizing the risk to human health and environment. So if we're going to use it to irrigate a golf course, obviously we want it to be reduced in pathogens because we don't want golfers obviously walking through that with their cleats, picking up any kind of pathogens, and maybe tracking that into their car or tracking that into their home. I know most of those guys take their shoes off. But, those types of things we need to think about when we're talking about reuse. So it talks about safety. Once again, having Coast Guard approved flotation devices out towards where your effluent discharges is important. When we talk about collection of samples, and this is of all samples, some characteristics change so rapidly that they should be measured immediately. This is true of temperature, pH, and dissolved oxygen. We really want to, I believe the EPA wants us, and chlorine wants us to record that within 15 minutes or less. So it should be immediately that we are measuring those and reporting those. So when you go out to your effluent and you're taking a sample, you should have those portable kits ready and calibrated so that we can give accurate, up to date because they change rapidly. Um, for our other samples, we want to make sure we have preservative in those that need preservative. When we talk about sampling, obviously we've discussed grab samples, composite samples. Grab samples is when you take a sample at an individual time at that moment. Just a snapshot of what's going on in that moment. Composite samples are a 24-hour sample that takes maybe 100 mils every 24 hours. Flow metering, just like we meter the flow in the headworks, we also want to meter the effluent flow, because we report that to EPA. Discharge of surface waters. Before discharge, wastewater is treated to protect the health of people who may come in contact with it, to prevent nuisances due to odors and unsightliness, and to prevent wastewater from interfering with many uses of the surface water. So before we discharge any surface water, we should make sure that we're not adversely impacting any of the receiving waters with any kind of odors, visible floating substances, grease, or abnormal colors. we should be monitoring our receiving stream. I know at our plant we'll take a E. coli upstream and a coli downstream because we want to see, you know, how how many colonies of E. coli are upstream, and then are we improving the downstream or um, degrading the downstream water with E. coli? And so it's important that we do stream monitoring. Once again, it's paramount that you use safety procedures when you are doing that because you are working in a flowing stream. So wearing the approved boots, to keep your feet from getting wet, and also the right sampling equipment because really, you want to get the water where it's flowing at its fullest peak and not just in a stream or eddy. We want to be a representative sample in our sampling. Temperature. So, when you take temperature, just know that it could change depending on the day that you're taking it, the time you're taking it. Are you taking it in August? Are you taking it in winter? Are you taking it from the top? Are you taking it from the bottom? Most streams will be cooler at night than during the day. You'll have all your seasonal variations. And so, a picture 2.2 will show a river crossing with typical sampling flows. Dissolved oxygen. Another thing we want to measure is our DO. We want to measure it on our receiving stream. We also want to measure it in our effluent because fish and aquatic life need that to survive. Cold water can at saturation hold more DO than hot water. So we just need to keep that in mind when we are measuring dissolved oxygen in either tank. And that's once again important, if it's a cold winter day and you're taking a river analysis, you want to do that DO right there and then because if you take it and bring it in the truck and then bring it into the lab, you can have that degradation of the temperature by the warmth of the truck. So on page 74, you have the reclaimed water applications. So the urban, we can use it for public parks, sporting facilities, private gardens, street cleaning, fire protection, vehicle washing, toilet flushing, air conditioners, dust control. Then you have your industrial use. So you could pump it to a factory where they use it as cooling water, recirculation towers, um, and then agricultural, food crops, pastures for milking animals, fodder, seed. Then we're divided up into a recreation, our golf courses, our boating, our fishing, then the environmental, we can actually pump it back into the aquifer and do an aquifer recharge. And then obviously for potable, not a lot of demand right now for potable reuse, but it's getting there. I've done some research through the internet, and there are some places around the world that are looking into potable reuse. So literally the waste coming from the stream, they'll take it, clean it up, and then drink it again. And so, that's coming down the pike as we lose water. One thing to remember is when you are doing dual irrigation or something, or dual, gray water and regular water. Distribution systems run a dual piping system to keep the recycling water that is not treated to the specifications for drinking water separate from potable water. So, there's always that potential for contamination. And if you're running pipes in the same building, you can have one pipe that is reclaimed wastewater that maybe you're using to run out to your grass to water your grass. And in that same building, we have pipes for drinking water. And so we want to make sure they're labeled and kept separate. And correct signage. Your end use requirements. What is it being used for? And that's really the standard that we are going to try to use to meet and to provide to um, our customers. Aquifer recharge, reclaimed water on page 80 can be injected into aquifers through wells or infiltration facilities to store and supply from non-potable uses in the future. Nuclear generation station feed water. The way they do that on page 83, lime is added to the effluent from the trickling filters to increase the pH to 11.3. The lime addition is used to precipitate solids to reduce magnesium and silica to control scaling problems. Lime reduces the phosphate by 95%. Um, and then after clarification, carbon dioxide is used. So for your specific industry that you're having, you know, we need to make sure that that water is not going to have an adverse effect with any of the equipment. And so every place that we have is going to be treated separately and differently to make sure that we're compliant there. Page 88, potable reuse. So, potable reuse involves the direct or indirect use of highly treated municipal wastewater as a municipal drinking water source. Um, so they'll call it the DPR in the book, um, but you know, once again, trying to use that uh, so that people can use it again to drink. Indirect is the treated wastewater that is discharged into the surface body water or ground aquifer and then used as a source of water is called IPR, indirect potable use. So let's say you have a municipality here in upstate, they discharge to a river, and then let's say Topeka, Kansas, then draws out of that river. That would be an example of an indirect potable reuse versus a direct potable reuse. It's more along the lines of you taking it straight out of the wastewater effluent and then reusing it. Um, uh, when we talk about uh, irrigation systems. So on page 96, irrigation systems apply water by sprinkling or surface spreading. Sprinkling may be fixed or movable. Um, when we can apply that to golf courses just with sprinkling to keep the water, the vegetation growing. You can see the different ways that you can do it. Sprinkling on page 99, sprinkling, you can flood the area or you can ridge and furrow it. Land disposal systems may generate side streams. The first side stream is wastewater percolating to the groundwater from the unlined storage reservoir. If the water stored in the reservoir is the final effluent from treated plant percolation down to the groundwater is acceptable. So, sometimes when you're storing it in a lagoon, if it's unlined and it is it's just a storage effluent treated lagoon, it may percolate down into the system, and it's kind of acting the same way as a leach system does in a common household. Um, one thing limitations using land treatment systems is you can get soil sealing, so the soil will actually be sealed off from the water because of extreme amounts of total suspended solids, and other issues can be prohibited from sprinkling systems. We want to monitor our our anything that we're adding to the environment for BOD, fecal flow, nitrogen, phosphorus, suspended solids, pH, total dissolved solids, and any of our metals. So that ends the chapter 2. I hope you enjoyed it. Thank you.